Okay, now the difference between EMF and potential difference. We have learned this. There's just one small thing that you need to be careful in answering this question. So if you go through the notes, here you can see that EMF is energy converted from other forms to electrical per unit charge. So chemical to electrical, that's the most common. But potential difference is energy converted from electrical to other forms per unit charge. If you go to the mark scheme, there is all possibility. Okay, EMF you will score, that's okay, but for potential difference you would just leave the answer as other forms. But if you look at this question here, it asks you with regard to a resistor. It is not just asking in the context of a common component. They are specifically saying it is a resistor. So in resistor, the other form is thermal. So if you had simply left it as other form, you would not get full marks. So you have to say it's electrical to thermal. Though they have given per unit charge in brackets, you better write it as well, because that's the full definition. So the mistake that's possible is you would simply leave it as other forms, but here you have to specify thermal. Then if you go to question 4, state Kirchhoff's second law. There was a student who knew both the laws, but he was confused which is the first one and second one. So you should not only know the laws, but you should also know the correct number. Once there was a lawyer. He knew the law according to which a person should get the sentence, but while he was arguing, he forgot the section number. So he stated the law and said to the judge, Your Honor, you know everything about the law, you know all the sections, so there's no need that I have to tell you which section. So you already know that, so you please consider and give it. So not only you should know the law, you should know which is the first one and which is the second one. So which is Kirchhoff's second law? The first law is concerned with the terminal junction, current entering the junction and leaving it. The second law is concerned with the electromotive forces. The sum of the electromotive forces in a closed circuit is equal to the sum of the potential differences. So there are 2 points here. Sum of EMF equals sum of PDs, and in a closed circuit. Even if you have no idea which is the first one and second one, if you take a look at the second question, if you look at the later parts of the question, that should hint you which law they require in that question, because they're not going to ask Kirchhoff's first law and put the remaining parts on second law. That's absurd, but it could happen, but very rarely. But yeah, so there are 2 points there. Then if we continue to this remaining part here, that I find quite interesting. It's a very peculiar circuit in that sense. You have a battery here and you have a battery here. The only consolation is they are not opposing each other. They're just connected positive to the negative and positive to the negative, positive to the negative and positive to the negative. So they are not opposing each other, but that's the only consolation. But otherwise it looks like a very peculiar circuit. So the EMF is set as 6, and another good news, negligible internal resistance, so EMF is equal to the EMF is equal to the terminal potential difference, terminal PD. And resistor X has a resistance 4 ohms and Y has a resistance 1.5 ohms. The resistance R of the variable resistor is changed until the voltmeter in the circuit reads 0. So that's what makes this circuit quite peculiar. Now here there are 2 points, and there's what does it mean when it says that the voltmeter reads 0? That means there is no potential difference between this point and this point, right? So if there's no potential difference between, so it means that there is no potential difference between those 2 points. And that's all the information that they are giving you, and then they're asking you to calculate the current in the circuit, the I. Well, the third good news is there is no I getting divided into branches. It's just one complete loop. So the I is going to go in round and round and round and round. So that's something good. So with all this, we know that this question falls under the context of Kirchhoff's second law, which talks about EMFs equals PDs in a closed loop, right? So we're going to use that law to solve whatever these questions are. So the current I, calculate the current I in the circuit, right? So if you want to apply Kirchhoff's second law, then we need to identify closed circuits, loops. So first you have to figure out how many loops are there in this. Well, for that, let me draw that circuit